Alright, in this video, we're going to be going over comparing and scaling investigation 2.3. So, the focus question is how can you find the unit rate in a description, equation, table, or graph? So, for a quick recap, you can think of the unit rate as what's the value when you have one of something. For example, if you have 1 gallon or 1 hour, how much is the other value when we have one of something? You might also hear the phrase constant of proportionality. These two words are interchangeable. So whether you think of the unit rate or the constant, those both mean the same thing. For example, in this equation, c equals 13n, 13 is going to be our constant. It's the number that's next to the variable. Okay. So here's our first situation. Fresh Fruit has a sale of oranges. They sell 10 oranges for $2. And for each one, we want to find the unit rate. So there are two ways of looking at the unit rate. We can look at it at cost per orange or how many oranges per cost. So let's take a look at this first one, cost per orange. Notice that cost shows up first, cost per orange. So we're looking at cost first. So let's put the $2 on top. So our ratio is going to be 2 to 10, right? Cost on top, oranges on the bottom. So how can I figure out the unit rate? How can I figure out the cost if I only have one orange? So to turn 10 into 1, we need to divide both sides by 10. So notice that we divide both sides by 10. 10 divided by 10 turns into 1. And then 2 divided by 10 is 0.2. So it's telling me for one thing, for one orange, it costs 20 cents, right? Or 0.2 of a dollar, 20 cents. All right, this is asking how many oranges can we buy for $1? So this is actually looking at it the other way around. So here we're looking at how many oranges can we buy for $1. So here our ratio is going to be 10 to 2. And I want to figure out how much is the rate when I have $1. So do you see how $2 is right here? I want to change $2 to $1. To do that, I'm going to divide both sides by 2. Divide by 2, divide by 2. And notice that we get a rate of 5 per 1. So I can buy 5 oranges for $1. So again, these are both unit rates because we're comparing it to one thing. Whether we have 1 orange or $1, how much is the other number? Okay, so let's go and fill in this table. Let's see, 2 to 10. If I want to figure out how much for $1, I can cut both of these in half. Okay, and from here, let's see, to go from 5 to 1, I can divide both of these by 5. 5 divided by 1, 1 divided by 5. So that's going to be 0.2. Let's see, now that I have 1, it's easy to scale up. To change 1 to 20, I can multiply both sides by 20 times by 20. So multiply both sides by 20. All right, and that equals 4. All right, if I want to find 11, I can scale this up to 1 times 11 times 11. So 0.2 times 11, which is 2.2. All right, if I want to find the cost for 2.6, I need to scale this up by 2.6. So I can multiply both sides by 2.6, and I get 5 times 2.6, which is 13. So using the unit rate, I can just keep multiplying it in order to get the values that I want. All right, for A3, how can we figure out the cost by using the unit rate? So if we know 5 oranges cost $1, how much can I buy for $5? Again, my scale factor is going to be 5. I'm going to take this ratio times it by $5, right? Again, I have 1. 1 times 5 is 5. So the number of oranges is going to be times 5, which is 25 oranges, right? How much do 25 oranges cost? Again, right now I have 1 orange. So I want to multiply that by 25 oranges. So I'm using my unit rate. I know 1 orange is 20 cents. Times it by 25, and I get $5. So notice that starting with the unit rate, I can just multiply to figure out what answer I want because I'm already starting off with one thing. Okay, so what does this equation tell you about the relationship between oranges? So this first equation is telling me if we tell the equation the cost, it will give us the number of oranges. So notice if I plug in cost, it's going to tell me how many oranges I'm going to get. What's another equation we can write? Switching the letters around, I can write an equation cost and number of oranges, switching the letters. But what would be my unit rate? So looking back at A1, so even though one unit rate is 5, the other one is 0.2. So let's use 0.2. Right, and this equation is telling me if we tell the equation the number of oranges, it will tell us the cost. So you can think of these two equations as backwards, right? One's asking for cost and will tell me the oranges. One's asking for oranges and telling us the cost. So again, they're kind of like two inversions of each other. So how can we identify the unit rate from these two? Again, the unit rate is 5 and 0.2, and they are always next to the variable. Okay. How does the constant of proportionality relate to the unit rate? Like we mentioned earlier, constant and unit rate mean the same thing. So let's go and make a graph for every 0.2. So for 0 oranges, this is going to cost $0. But if I buy 1 orange, it's going to cost 20 cents. 2 oranges are going to cost 40 cents, 60 cents. And I'm just going to keep going up by 0.2. So 5 oranges for $1, 1.2, 1.4, 1.6, 1.8, and $2 for 10 oranges. Okay. And notice that for a proportional graph, notice how it makes a straight line. So we have a straight line here. So here, let's look at the other equation. Again, if I tell it the cost, it'll tell me how many oranges I can buy. So if I spend $0, I get 0 oranges. But if I spend $1, I can get 5 oranges. $2, I get 10. $3, we can get 15 oranges. And see that it's going up by 5. 20, 25, 30, 35, 40, 45, and 50. Okay, moving to the next. So how can you use the graph to find the unit rate or the constant of proportionality? The unit rate will be on the graph when x equals 1. So what I mean by that is, if we look back here, how much does it cost for 1 orange? It costs 20 cents. Do you see when x equals 1, we're at the 1 spot? And 0, 1, 2 at 1. And over here, if we have $1, we can buy 5 oranges. So it's going to be the value when x equals 1. How much do we have when we have 1 of something? Again, unit rate means 1. So let's take a look at this another example. Normalized car uses 30 gallons to drive 600 miles. What's the unit rate for miles per gallon? So we want miles on top, per gallon, miles per gallon. So our original ratio is going to be 600 to 30. Again, miles on top, gallons on the bottom. How much do we want to figure out for 1 gallon? Again, I want to turn 30 into 1. So let's go and divide both sides by 30, divide by 30, divide by 30. So to figure out how much for 1 gallon, 600 divided by 30 is going to be 20. So we can draw 20 miles in 1 gallon, which is pretty good. All right, let's go and see what the unit rate is for gallons per mile. So let's put gallons on top. So it's the same ratio as just looking at it the other way. Gallons on top, miles on the bottom. And this time I want to figure out how much for 1 mile. How much gas for 1 mile? So again, we're going to divide by 600. 600 divided by 600. Again, we're trying to figure out how much for 1 mile this time. 1 mile is on the bottom. And 30 divided by 600 is 0.05. So what relationship is the graph showing? So notice that at 1, we're going 20 miles. So 1 gallon for 20 miles. Here, 1 gallon for 20 miles, we're using this rate here. So the equation is D equals 20 per gallon. Again, for each gallon, I'm going to multiply it by 20. 2 gallons, going to multiply that by 20. 3 gallons, multiply that by 20. So for the number of gallons, I multiply by 20. Which point represents how far he's gone off for 1 gallon? So for 1 gallon, the point is going to be 120. And which coordinate represents how far a normal line goes on 0 gallons of gas? So if we have no gas, then obviously we can't move the car at all. So at 0, we move 0 distance. All right. So Josh uses the following proportion to solve for x. So this is one of our methods that we looked at in the previous investigation. So I can scale 30 down to 5 by dividing by 6. 30 divided by 6 equals 5. But if I scale one part of the ratio, I need to scale both. So 600 divided by 6 is going to be 100. So that's one way of solving. We can scale both sides to get to a smaller amount. Again, instead of using 30 gallons, if we reduce it to 5 gallons, we're also going to reduce the top as well. All right, we're going to go 100 miles. But it turns out we can also solve it by using the unit rate. How far can we travel if we have 5 gallons? Again, notice that we're trying to figure out how many miles we're traveling. So we want miles on top because that's what we're trying to figure out. and we're going 20 miles for 1 gallon, all we need to do is just times it by 5 for 5 gallons. 20 times 5, which is 100. Notice that both of these methods give us the same answer, right? One's using the unit rate, how much for 1, and the one is just scaling down, right? Both strategies are helpful. So let's go and talk about unit rates one more time. What's the cost per box? So again, we're going to write a ratio. We want cost on top, box on the bottom. So here, cost is $6 for 7 boxes, 6 to 7. Right? Here, we want to find the cost per box for fresh fruits. So they sell $5 for 6 boxes. And notice that the fresh fruits is slightly cheaper, about like 2 cents cheaper. So the fresh fruits is going to be a little bit cheaper. So how can you find the unit rate in the description, equation, and table? In a description, we can find the unit rate by dividing the ratios. In an equation, the unit rate is next to the variable, or let's call it the independent variable. In a table, it's when the value equals 1. And same thing in the graph. In a graph, the unit rate is when x equals 1. All right, I'll leave this here for a second. We have 2 practice problems. So in the practice problem, we know that 50 pounds of milk makes 5 pounds of cheese. So we have 5 pounds of milk, that makes 50 pounds of cheese. If I double the amount of milk, I can make double the amount of, if I make double the amount of cheese, I need double the amount of milk. If I triple it times 3, I need 3 times the milk. If I quadruple it, I'm going to need 4 times the milk. 50 times 4, which is going to be 200. Right, and if I need 10 times the milk, again, 50 times 10 times the milk, I'm going to need 500 pounds of milk. So let's graph this. Let's see. At 5, we're at 50. 10, we're at 100. 15, we're at 150. 20, we're at 200. And 55, we're at 500. So what's the constant proportionality? Again, the constant proportionality is how much for 1. So if I want to make 1 pound of cheese, how much milk do I need? So notice that at 110 is on the graph. At 1 pound of cheese, I need 10 gallons of milk. Again, another way I can figure that out, I can take 50 divided by 5, and that'll tell me how much it takes to make 1 pound of something, right? To make 1 pound of cheese, I need 10 pounds of milk. So my equation is going to be milk equals 10 pounds for each pound of cheddar. Again, how much cheddar I need, I multiply that by 10, and that's going to tell me how much milk I'm going to need. All right, and finally here, let's go and write our cost per item. So these are all going to be ratios. And we want cost on top and item on the bottom. So $4.50 for 3 dozens. So 1 dozen is going to cost $1.50. Here, $4.80 for 30 bottles. So 1 bottle is going to cost 16 cents. And here, cost on top, over 24 ounces. So 1 ounce is going to cost $12. Right? 1 ounce is going to cost $12. So that's our unit rate. Again, unit rate is how much for 1.